Is the night sky actually an illusion? When we look up, we aren't seeing the universe as it is now, but as it was, ghosts of light from centuries ago. We dream of colonizing Mars, of becoming a multiplanetary species. But the cold truth is that we might be trapped in a cosmic cage. Our closest neighbor, Proxima Centauri, sits just 4.24 light-years away. On a galactic scale, that is the equivalent of a neighbor's front porch. Yet, this tiny gap represents a wall so high that humanity may never climb it. Why is it that our nearest neighbor might remain an eternal, unreachable dream? In 1915, when Robert Innes first spotted this faint red dwarf, no one knew it would become a symbol of human limitation. It is smaller than our sun, cooler and invisible to the naked eye, but it is our backyard. 4.24 light-years. It sounds manageable, doesn't it? But here lies the first great deception of space. 1 light-year is 9.5 trillion kilometers. Proxima Centauri is 40 trillion kilometers away. To put that in perspective, if you drove a car at 100 kilometers per hour without ever stopping, it would take you 45 million years to arrive. You would have had to start your engine when the first primitive mammals were barely appearing on Earth just to arrive today. Is our technology truly capable of conquering such an infinite void? Some argue that we are building faster ships every day. We have the Parker Solar Probe, a marvel of engineering that screams through space at 700,000 kilometers per hour. It is the fastest object we have ever made. But even at that blistering speed, the journey to Proxima Centauri would take 6,300 years. The entire recorded history of human civilization would pass by before the probe even reaches the halfway point. Even the legendary Voyager 1, which has been traveling since 1977, would take 73,000 years to get there. And it isn't even pointed in the right direction. We are moving at a snail's pace on a cosmic stage. What is it that stops us from simply going faster? We run headfirst into the most merciless law of physics, the rocket equation. To reach another star within a human lifetime, we need to reach at least 10 to 20% of the speed of light. This isn't just an engineering challenge, it is a battle against the fundamental nature of mass. To gain speed, you need fuel, but fuel has weight. To move that weight, you need more fuel. The math spirals into a nightmare. To accelerate a medium-sized ship to just 10% of light speed, you would need more energy than the entire world consumes in a year. And that is only for the first half of the trip. How do you plan to stop? To decelerate at your destination, you would need to carry that same massive amount of fuel all the way there. Can we ever find a source of power that breaks the chains of the rocket equation? Let's imagine a miracle. Let's assume we invent a nuclear pulse engine or a fusion drive that solves the fuel problem. We are finally flying through the dark at millions of kilometers per hour. But now, the vacuum of space reveals its teeth. At 20% of the speed of light, space is no longer empty. It is a minefield. At that velocity, a single grain of dust striking your hull has the explosive power of a hand grenade. A pebble becomes a nuclear strike. There is no time to steer away. There is no shield strong enough that wouldn't make the ship too heavy to move. Are we building a starship, or are we building a high-speed coffin? Even if the hull holds, the cargo is fragile. Human biology was never meant for the interstellar void. Outside the protective bubble of Earth's magnetic field, the crew would be bombarded by relentless cosmic radiation. Decades of high-energy particles tearing through DNA. The risk of cancer would skyrocket. Cognitive functions would wither. To shield the crew, we would need meters of lead or water, adding thousands of tons of weight back to our ship. We are back to the energy problem. Is it possible that the stars are not meant for biological life, but only for the machines we leave behind? Silence. That is the next hurdle. Communication across 40 trillion kilometers. Even at the speed of light, a simple hello from Proxima Centauri takes over 4 years to reach Earth. If the crew encounters a crisis and asks for help, they will wait 8 years for a reply. There is no mission control. There is no Houston, we have a problem. The crew of an interstellar mission would be the loneliest humans in history, drifting in a silence so profound it could shatter the strongest mind. Can the human psyche survive being truly cut off from the cradle of its species? So, we turn to the last resort, the generation ship, a massive flying ecosystem where people are born, live, and die, hoping that their great-grandchildren will be the ones to finally see a new sun. It sounds like a grand sacrifice, but look at the darkness beneath the surface. How do you maintain a closed-loop system that must function with 100% perfection for centuries? One failed valve in year 150 kills everyone in year 200. And more importantly, how do you keep the society together? What happens when a generation is born that never chose this mission? What happens when they decide they would rather turn the ship around? Or when a civil war breaks out in a ship where there is nowhere to run? The picture is sobering. It is not just one obstacle, it is a chain of insurmountable barriers. Distance, time, energy, radiation, and the fragility of the human soul. Every time we solve one problem, the laws of physics present us with two more. Proxima Centauri sits there, mocking our ambition. Is it possible that the universe is designed to keep us apart? That every star system is meant to be a lonely island in an ocean too vast to cross? We can see the planets orbiting Proxima with our telescopes. We can analyze their air and dream of their soil. But seeing is not reaching. Perhaps there is a hidden humility in this realization. We don't have to physically stand on a planet to understand its beauty. Through the James Webb Space Telescope and the observatories of the future, we are becoming cosmic voyagers of the mind. We are learning to search for life from across the fence. We are discovering that while we may never reach our next star, we are not blind to its secrets. Does our inability to reach the stars make them more valuable? Or does it simply highlight how precious our own small blue world really is? Proxima Centauri will remain a red ember in our sky, forever out of reach, forever haunting our dreams. We may never walk on its planets, but we will never stop looking. Is it our destiny to be the eternal observers of a universe we can never touch? Or is there a secret yet to be discovered? A loophole in the laws of physics that will one day open the door. Until then, the stars will keep their distance, and we will keep our wonder.